Ependymomas are primary brain tumors of ependymal cells, which line the fluid-filled pockets in the brain. In this scene, we'll give you a visual mnemonic to help you remember all the bits and pieces for this brain tumor. I just want to start by saying, pandas are pretty cool, right? Take a look at these cute pandas here. Yep, pandas are a recurring symbol for ependymoma, or ependymoma. Get it? Panda for ependymoma. Pandas also help peg the cell type that form these tumors, ependymal cells, or ependymal cells. These are cells that line the fluid-filled cavities, or ventricles, of our brain. Now, I know you can't tell from this picture, but one of the pandas is male, and the other is female. You see, the panda is an endangered species. To grow the panda population, our zookeepers have been trying to get the pandas to mate. Anyway, just remember our pandas here to remember both the tumor, ependymoma, and its cell origin, ependymal cells. Next, take a look through the grating. It's daytime, which is why these pandas are up and about. You see, our zookeepers really seize the day when these pandas are awake to throw these pandas together in the hopes that something will happen. On another note, daytime is our symbol for childhood, and this should help you remember that ependymomas are brain tumors that classically occur in children, because children are like the morning, bright and brimming with potential. And adulthood is like the night, because, well, you know, the day is older. Anyway, just remember that our zookeepers are using the daylight to create opportunities for the pandas, and you'll remember that ependymomas usually happen in children. Afternoon delight. Alright, so how else do we know this is a zoo? By the door, of course. See the vents in the door? These zoo doors always have vents for some reason. I guess the animals have to breathe? I think it improves the airflow for our animals here. For our loyal Pixarize users out there, this door should ring some bells. Yes, the door is our recurring symbol for the number 4, because door sounds like 4, right? And the vent, well, that's here to help you remember ventricles. Vent for ventricles, you see? Putting this together, this door vent should make you think of the 4th ventricle. The 4th ventricle is one of the 4 fluid-filled cavities in the brain, and it is specifically located near the pons in the cerebellum. Notably, the 4th ventricle is the most common site for ependymomas, which is why that door is here. Just remember our door vent here, and you'll remember the 4th ventricle, alright? Alright, I should probably be upfront with you. We're not actually human. Just take a look at my colleague. We're different in many ways, but the most obvious is our heads. We have what you might call a brain in a fluid-filled jar, because we've evolved to where we don't need the rest of our body. Nah, this is no sci-fi, we're real. But, my friend got a bit careless today with the brain liquid. Looks like he put in too much, and all that extra brain fluid is getting everywhere. Great. By the way, doesn't this picture somehow remind you of hydrocephalus? I mean, hydrocephalus basically means too much cerebrospinal fluid, right? Hydrocephalus can occur in ependymoma, and it's not too much of a stretch to reason why this happens. Recall from earlier that ependymomas usually arise in the 4th ventricle. What I didn't tell you is that the ventricles of the brain are connected, like pipes in one big fluid drainage system. Ependymomas are tumors that can sometimes block these pipes, causing the fluid to build up above the block. This leads to cerebrospinal fluid overload, also known as hydrocephalus. Additionally, all this extra fluid takes space and can increase the pressure inside your skull. As you can imagine, this is very bad for your brain, and patients with ependymoma typically have a very poor prognosis. Just picture my friend's extra brain fluid here, okay? Alright, back to the pandas. Looks like our buddy's pulled out all the stops today. He's even brought out the rose petals. Come on, you pandas, can't you feel the love in the air? But where did all these rose petals come from? Actually, they're local. From that rose bush right there. Notice how the roses are being watered by a red hose, which kind of makes me think of a blood vessel. Now comes the good part. Don't roses make you think of rosettes? So if the red hose is a blood vessel, these pink rosettes around the red hose should help us remember perivascular pseudorosettes. Biopsies of ependymomas will show characteristic perivascular pseudorosettes. Here's a picture. See the blood vessel in the middle? The pink tumor cells form a flower-like ring, or rosette, all the way around the blood vessel, or perivascularly. Technically, this is called a pseudorosette instead of a true rosette because the central structure isn't part of the tumor. I don't want to get into the weeds about true rosettes versus pseudorosettes. Instead, just remember the perivascular bit. It's way more important for step 1. Alright, it looks like nothing's working. Even with all these romantic rose petals around, the pandas just aren't feeling it. Well, desperate times call for desperate measures. Take a look at the whip my friend is holding. Maybe he's trying to scare the pandas into mating? What is this, 50 Shades? The top of the whip is wavy and hair-like, and it kind of reminds me of cilia. Yeah, cilia, the hair-like projections found on ependymal cells. Furthermore, I want you to look at the base of the cilia-like whip, at that big rod there. This rod at the base of our cilia should remind you of rod-shaped blepharoplasts, also called basal ciliary bodies. Electron microscopy of ependymal cells reveal high numbers of these rod-shaped structures which sit at the bottom of cilia. To understand why this is, think back to the function of ependymal cells. Ependymal cells line the fluid-filled cavities of the brain and are responsible for moving fluid around. This movement happens by the way of cilia. Yep, ependymal cells have cilia. And each cilia has a blepharoplast, or basal ciliary body. So, if ependymomas come from ependymal cells, it should make sense that they also have high numbers of blepharoplasts. Just remember our rod-shaped whip base and you'll remember this finding. So in summary, pandas are really just finicky creatures. Let's recap. Ependymomas are primary brain tumors originating from ependymal cells, which line fluid-filled pockets in the brain. They most commonly occur in children and classically arise in the fourth ventricle. Because of their ependymal location, these tumors can block the drainage of cerebrospinal fluid, causing fluid buildup known as hydrocephalus. On biopsy, perivascular pseudorosettes are a key pathologic finding to look out for. Finally, electron microscopy will reveal high numbers of blepharoplasts, or basal ciliary bodies, a finding that is almost pathognomonic for ependymoma. Alright, maybe it's time to just let nature take its course. Pandas, you go have fun, okay? Until next time.